Namaste friends, my name is Nisha Thakur and I am a maths online tutor. I am the founder of Nisha Tutor. In this video, we will do a question related to rational zeros of a polynomial. We already done three questions in my last videos, and we already discussed about rational zeros theorem, and we know the guidelines how to finding the rational zeros of a polynomial. So first find out least possible zeros according to this theorem, and then divide and use synthetic division to evaluate the polynomial at each of the candidates for the rational zeros that you found in step 1. When the remainder is 0, note the quotient you have obtained. Okay, and then repeat these two steps. Stop when you reach a quotient that is quadratic or factors easily, and use the quadratic formula or factor to find the remaining zeros. Here is today's question using the rational zeros theorem and the quadratic formula. Here given this polynomial, find the zeros and sketch the graph of p. So here first question, possible rational zeros, zero of p, factor of constant term divided by factor of leading coefficient according to this rational zeros theorem. Okay, so here factor of constant term is factor of 10 and factor of leading coefficient 1. The leading coefficient of p is 1, so all the rational zeros are integers. So the possible rational zeros of p are here factor of 10, 1, 2, 5, 10. So possibilities are plus minus 1, plus minus 2, plus minus 5, plus minus 10. And we can divide, use synthetic division to find out which are the zeros of the given polynomial and which are not. Okay, so let's start here. In synthetic division, we write here coefficients of the dividend. So x to the power 4 coefficient is 1. Here x to the power 3 coefficient is minus 5. X square minus 5. This is 23 and this is 10. Okay. Now we can divide by 1. So 1 bring down here. 1 times 1 is 1, minus 4. Minus 4 times 1, minus 4. This is minus 9. Minus 9 times 1 is minus 9, 14. 14 times 1 is 14. And this is 24. So here remainder is not 0. It means this is not a 0 of the given polynomial. Let's try with 2. Again write your coefficient and divide by 2. Okay, so here bring down 1. 1 times 2, 2. Minus 5 plus 2, minus 3. Here multiply, so minus 6. This is minus 11. Minus 11 times 2, minus 22. And this is 1. 1 times 2, 2. And this is 12. Again, this is not 0. It means 2 is not a 0 of the given polynomial. Let's check with 5. We can divide by 5. Now bring down here 1. 1 times 5, 5. This is 0. 0 times 5, 0. Minus 5. Minus 5 times 5, minus 25. It's minus 2. Minus 2 times 5 is minus 10. And finally we got 0. It means 5 is the 0 of the given polynomial. according to factor theorem, we can say x minus 5 is the factor of this given polynomial. Okay, so we can write given polynomial is x to the power 4 minus 5 x to the power 3 minus 5x square plus 23x plus 10 x minus 5 is the factor of the given polynomial x minus 5. Here 5 it means x minus 5. Okay. Now what is the quotient to this remainder? This is minus 2, which is constant. Okay. This is constant and this is coefficient of x. So minus 5x. This is coefficient of x square. So this is 0. We don't write. Now here x to the power 3 coefficient. So it is 1. So we can write x to the power 3. Now again we have to factorize this and we will use synthetic division method for this. Okay. So we know that we already here did 1 and 2 are not the zeros of the given polynomial because we didn't get remainder 0. So we can start minus 1, minus 2 like that. Okay. So here this coefficient of this polynomial here x to the power 3 is 1 x square, no here not a term, so we can write 0 or you can write from here. Okay, 1 0 minus 5 minus 2, or you can write from here 1 here not a x square term, so we can write here 0 x coefficient is minus 5 and this is constant. Okay, and we can divide by negative 1. 1 bring down here, 1 times minus 1 is minus 1, this is minus 1, minus 1 times minus 1 is 1, and minus 5 plus 1 is minus 4, and minus 4 times minus 1 is 4, and this is 2. So remainder is not 0, it means minus 1 is not a factor of the given means this polynomial. Okay, this part. Now again write this, and now we can divide by minus 2. Okay, 1 bring down here, 1 times minus 2 is minus 2, 0 minus 2 is minus 2, minus 2 times minus 2 is 4, minus 5 plus 4 is minus 1, minus 1 times minus 2 is 2, and this is 0. Remainder is 0, it means minus 2 is the 0 of the given polynomial, or we can say x plus 2 is a factor of the this polynomial. So we can write here x minus 5 x plus 2. Okay, x plus 2 here minus 1. Okay, and because next to remainder this is constant, this is coefficient of x, this is coefficient of x square, so minus 2x, and this is x square. Okay, x square coefficient is 1, minus 2 x coefficient is minus 2, and this is constant term. Okay, now here we can apply because this is quadratic, so we can easily solve by quadratic formula. For this we have to use quadratic formula, x square minus 2x minus 1, x square minus 2x minus 1. Here we can compare with ax square plus bx plus c. Okay, and here a value is 1, b value minus 2, and C value -1, minus B plus minus B square minus 4AC upon 2A. Okay, now we can substitute here values. Minus B value -2 plus minus B value is -2, so square minus 4, A value 1, B value C value -1 upon 2A value 1. Minus minus plus 2, and here -2 square is 4. This is minus minus plus, and 4 times 1 times 1 is 4 divided by 2. So here 2 plus square root 4 plus 4 8 and divided by 2. 2 plus minus square root 8, we can write 2 square root 2 divided by 2. We can take common 2 from the numerator and we get 1 plus minus square root 2 divided by 2. This is cancel 2 and 2. We get 1 plus minus square root 2, and this is x value. Okay. Our final here factorization is x minus 5, x plus 2, and for this we can take this is x um, minus 1 plus square root 2, okay, and x minus 1 minus square root 2, this, okay, because we got this value 1 plus square root 2, 1 minus square root 2. So we can write like this. Zeros of the given polynomial is 5, minus 2, 1 plus square root 2, 1 minus square root 2. These are the 4 zeros of the given polynomial. Okay. So zeros of the P is 5, minus 2, 1 plus square root 2, 1 minus square root 2. Okay. Now we can sketch the graph of P in the given polynomial. Leading term is even, and here leading coefficient is 1. It means our graph looks like this, open upward, and behavior is x tends to infinity when y tends to infinity, and if x tends to minus infinity, y tends to infinity, positive infinity. Okay, and here when we put square root 2 value 1.4, so this is 2.4, and here when we put this, so we get 0, negative 0.4. Okay, so our zeros are 5, minus 2, 2.4, and minus 0.4. So our graph looks like this. So here are the zeros of the this polynomial. Okay, this is minus 2, minus 0.4, 2.4, and 5, and graph open upward. Okay, here and behavior when y tends to infinity, x tends to infinity. When y tends to infinity, x tends to minus infinity. And this is, we already discussed about graph in my last video, so you can check how to draw. Okay, you can find out extra points between two zeros, and if negative sign, it means below the or this x-axis. If positive, it means above the x-axis. So you can take test points between zeros. Okay, and check which type of graph. So really easy question, how to find out zeros and use these rational zeros theorem, and these guidelines are very important. But if you have any doubt, please ask me, and if you liked my video, so please like, share and subscribe my YouTube channel. Have a great day.